Hey, my name is Mike and this is Learn Chemistry Now! In this video we're going to go through a couple practice problems involving density. So our first problem is calculate the density of cadmium, and that's CD on the periodic table, if 1.00 times 10 to the 2 grams of the substance occupies a volume of 11.4 cubic centimeters. And there's a question mark at the end, so it would be cubic centimeters? So this is a very basic problem. It's just going to show us the formula. And the formula for density is rho equals mass over volume. So this is the Greek letter rho, and it's the symbol for density that we're always going to use. It almost looks like an upside down D, if that helps you remember. And so rho, let's just substitute our numbers in. Rho is going to equal 1.00 times 10 to the 2 grams over 11.4 cubic centimeters. And so that's going to give us, once we plug it into our calculator, 8.75 grams per cubic centimeter. So that was easy, right? Let's move on to something a little more challenging. Okay, our second problem. What is the mass in grams of a cube of silver whose density is 10.49 grams per cubic centimeter? Remember, this is rho, the symbol for density. And the side of that cube is 3.00 centimeters long. Okay, so this is a two-part problem. So let's start with our density formula and sort of set it up to see what we can do here. So we know that density equals mass over volume, but here we're trying to solve for mass. So we're going to have to get the m by itself. We can do that by multiplying both sides by the letter v. These v's cancel out, and now we have mass equals volume times rho, or density. Okay, so that's what we have to figure out, but we don't have the volume. We do have the density, but we don't have the volume. We only have this, whose side is 3 centimeters long. So we're going to have to find the volume, and we can do that by using the formula for volume. And the volume of a cube is just going to be length cubed, because all the sides are equal in the cube, right? So we just have to multiply the 3 by itself and then by itself again. So volume equals 3.00 centimeters times 3.00 centimeters times 3.00 centimeters. And thank you for bearing with me. It's going to equal 27.0 centimeters cubed. Okay, why did I put 27.0 and not 27.00? Because this has 1, 2, 3 sig figs, and likewise my answer is going to have 1, 2, 3 sig figs. Okay, so let's substitute in the formula now. Mass equals 27.0 centimeters cubed times 10.49 grams per centimeter cubed. The centimeters cubes are going to cancel out, and we're going to be left with grams, which is what we want, right? So the mass is going to equal 283, and I'm just going to stop right there and put a point. Grams. Now, why did I do that? Once again, 3 sig figs. 1, 2, 3. That's what we're given. That's what we end with. So 283 grams is going to be our final answer for this one. Okay, so this would be our last density practice problem. A cylindrical rod made of silicon, and the density of silicon is 2.33 grams per centimeter cubed, is 21.3 centimeters long and has a mass of 5.00 kilograms. What is the diameter of the cylinder? Okay, so this is a two-part problem, and right off the bat, I'm going to first look at the units that we're given. So we're given density, and we're given mass. So having both of those shows me that we can use the density formula to figure out the volume. And then once we have the volume, we can use this length and the formula for volume of a cylinder to figure out the radius and therefore the diameter of the cylinder. Let me show you what I mean. So I've sketched out a drawing of our cylindrical rod, 21.3 centimeters, and we're trying to find the diameter. Now density is mass over volume, and so we can rearrange this formula in terms of volume by multiplying both sides by volume and then dividing both sides by density to get volume equals mass divided by density. But first, we have to convert our density to the same units as our mass. So notice our mass is in kilograms and our density is reported in grams. So we need to change this to kilograms, and we can do that by simply dividing by 1,000. The grams cancel out, and we get 0.00233 kilograms per centimeter cubed. So now we put this in here. So we're putting this number over here, and volume is 5 kilograms divided by our density, which we've changed the units on, 0.00233 kilograms per centimeter cubed. And we plug that into our calculator, and we're going to get 2,145.9227, lots of decimals, or we can just round it. So notice that all of our units in the problem have 3 sig figs, 1, 2, 3, 1, 2, 3. So we can just use 4 sig figs here just to be sure that we're not going to make any rounding errors, and simply round to 2,146 centimeters cubed. So now we've got our volume, and so we can set up the volume of a cylinder equation, which looks like this. Volume of a cylinder equals pi times radius squared times height. And remember that our diameter, which is what we're trying to find after all this is done, is simply equal to double the radius. So if we get the radius, we essentially have the diameter. Solving this equation for r squared, we can divide both sides by pi h and get r squared equals volume of a cylinder divided by pi h, right? And then we can get r by itself by taking the square root of that value. So r is going to equal the square root of the volume of the cylinder divided by pi h. And now we can plug our numbers in. Our volume, remember, is 2146 centimeters cubed. Pi, we can use 3.1416. And our height is our length from the problem, which was 21.3 centimeters. So in this case, the height and the length are going to mean the same thing. So we get 5.66 once we plug this into our calculator. And remember, d is 2r, so we just multiply this number by 2, and we get 11.3 centimeters. Hey, thanks for watching, and if you enjoyed this video, please like the video and subscribe. I think the buttons are probably down here somewhere. Thanks a lot. Bye.